to a new IRES seminar for which we gather on the unceded territory of the Musqueam people. Something that I wanted to share today is that Dr. Robin Wall-Kimmerer, who, among many other things, has written the book Braiding Sweetgrass, came to give a talk recently at UBC. And when she was talking about what it means to have and develop and be in a relationship with the land, she highlighted the role of education as a form of reciprocity. So as a way of giving back to the land and to the people some of the gifts of learning that you've received. And I like thinking about this idea because I think it puts in a different perspective the act of writing a paper, of presenting your work, of putting yourself out there than what is traditionally emphasized in academic settings. And I wanted to share, going with that thought, an excerpt of the book that I've enjoyed, which says, "We may not have wings or leaves, but we humans do have words. Language is our gift and our responsibility. I've come to think of writing as an act of reciprocity with the living land, words to remember old stories, words to tell new ones, stories that bring science and spirit back together." And this will mean something different for each of us, but I found it useful as a source of inspiration to try to implement some changes and some improvements among the things that I do. I'm really happy now to introduce our speaker today, Dr. Qingshi Tu, who is an assistant professor of industrial ecology in the Department of Wood Science in the Faculty of Forestry at UBC. His research focuses on life cycle assessments, techno-economic analyses, and producing open source resources to enable more of that work. He is leading the Sustainable Bioeconomy Research Group, which combines industrial ecology principles with computational modeling to promote the sustainable development of the bioeconomy. And I'm excited to hear about your research today. And this is the same one.
I'll just kind of hold it. All good? Okay. Thank you very much for coming. Spend one of the few afternoons that's still sunny outside, right? So we're gonna go into the rainy side. So I really appreciate it actually come to my talk. And also a quick poll, like how many of you actually attended my talk a month ago in the early career research symposium? Okay, Emily, okay. So for Emily, I have a few new jokes for you, but when you hear the old one, please also laugh, all right? Yeah. So so it's my great pleasure to actually share with you some of my recent research projects related to applying, like AI, particularly large language model to LCA. So I will probably spend the first 30 seconds to talk about what is LCA. So because I feel like many of you probably are more or less kind of have knowledge about LCA, right? So some of the key takeaways, if you talk to anybody who never actually did LCA, is that you basically show the person this kind of circle, right? So, and this basically means in order to solve the problem, you should have a systems view, right? So not just looking at, for example, the use of the products, because, for example, in many cases, you use the electricity, you don't see the emission. But if you go backwards, like upstream, you will see the emission from, for example, power generation, right? Similarly, if you look at, for example, the treatment of some of the products, it may actually, for example, decompose, generate methane in landfill. That's also something we need to think about when we try to quantify the environmental impact of a product, right? So it's basically a full cycle. And for some of you, you've probably seen this graph multiple times, right? So that's basically a guiding principle of how to do LCA. 4 phases, right? The first one is goal and scope definition, like define what you want to analysis, draw the boundary, what to include in your analysis. How do you define a functional unit, which basically means you can compare apple to apple if you want to do LCA to compare the impact for 2 different products, right? And then we'll move on to, which is arguably the hardest part, which is the inventory modeling, where you need to collect different types of data, right? So then I will focus most of my talk today on this 2 types of data, foreground and background. So a little bit, I think an intuitive example about foreground versus background is when you, for example, make something, right? So if you make a cup, you somehow use energy, you know how much electricity you want to use. So that's a foreground, how many kilowatt hour of electricity. And the background data is how that much of electricity is produced, right? You use the same amount of electricity in BC versus in other places, it will have different impacts. That's where the foreground get connected with background data. In order to do the LCA, you need both of the information. And then once you have this kind of this sort of data, then you can do the impact assessment, meaning that if you know to produce 1 kilowatt of electricity, here's the amount of CO2 emission, then you will, let's say methane emission, right? Because we know the climate change impact of methane is different from CO2 just because of its own, the nature of the molecule and also the concentration in the atmosphere, right? So how do you basically convert the, what we call the inventory, which is, for example, certain amount of emission into the actual impact? That's where you see kilograms of CO2 equivalent. That small e means you basically translate different inventory emissions into impact using the same unit. That's where you do the impact assessment, right? And then another very important thing, as I often teach in my courses to my students, is that once you complete the model, you're lucky enough to have good data, you generate results. How do you make sense of the results? Especially if you work for a client, right? So once you show the graph, and then what's next, right? So the interpretation phase is very important. You need to highlight, for example, the major contribution of to the environmental impact of your entire product lifecycle. How can you take actionable, like strategies to actually help reduce the impact? So that's the fourth kind of phase. So again, very, very quick crash course on what is LCA and how you can do it, right? Then naturally, I think if you ever done an LCA project, or if you think about doing an LCA project, usually the starting point is that you have a product, you have a service. Your client probably come to you and say, okay, I don't know exactly what's the environmental impact of my product, right? So you start with 0. And then after you do LCA, you get some information, which is actually a pretty big win. You go from 0 to 1. It's a very large change, right? So because, you all of a sudden you start from knowing nothing to knowing something, but we don't really just end there, right? So there are a lot of nuance to doing LCA. So unfortunately, there's not a very clear way of defining a good and bad LCA, but going from 0 to 1 is not enough if you want to have a meaningful understanding of the environmental impact. And then how can you actually basically get a more insightful information from doing LCA is that you will have to address some of the challenges. And one challenge is related to data availability, right? So think about modeling, right? So modeling basically is abstraction of the physical world, right? So you have a mathematical model because you have a physical object you need to describe, right? Or in another case, if you have a horse and then your model is drawing it on paper, that's also a modeling process, whether you're aware of it or not, right? And then accordingly, if you have really good data, detailed data that's really representative of this, the physical system, then you can have a pretty good model in this case, right? But the reality is that in many cases, as you do more and more LCA, you realize that you probably will move most of the time in terms of finding data, you're on the right-hand side of the figure. So in many cases, you have to use what we call a proxy. It's like a similar process. And even in the other case, you have to, ideally you should, but shouldn't, but sometimes you have to do oversimplification. So this means if people only look at the conclusion based on oversimplification, you probably won't be able to guess what you're drawing, right? So similar thing for LCA is that if you oversimplify certain data because you just don't have a good availability of the data, your results will not be as meaningful, right? So, so in order to have really meaningful LCAs, basically studies and conclusions, data availability is a very big challenge, right? So specifically, remember I said I'm going to focus on foreground and background, right? So if you think about when you do LCA, in many cases, for example, so this is a bit vague here, but that's a process simulation for understanding the energy consumption for making hydrogen from biomass, right? So, but if I don't have the experiment set up, I don't know how much electricity I use, then I don't have this kind of foreground data to put into my LCA model. So what you can do is, for example, if you're a chemical engineer, you're good with, in this case, simulation, you can create a hypothetical hydrogen production facility and come up with, for example, the heat duty, the electricity consumption, right? And then, of course, naturally, not everybody's chemical engineer, and chemical engineers are different, right? So some of them cannot do this. So how can we actually improve the data availability when we are facing this kind of issue? So in the past 5-10 years, people started to more and more kind of lean towards using machine learning-based approach, right? So this is a recent paper published from a group at Berkeley. Basically, what they did is actually they create about 10,000-ish, even more simulations of a same technology, different conditions. Then you have a wide enough coverage of the training data. Then you can fit a regression model on that. Then later, if people want to understand, okay, what is the impact or what is the, for example, the energy consumption for a particular process, they don't have to recreate the whole simulation model, but just using a regression equation. So that seems to be a more user-friendly way, right? So that in theory should actually help us to minimize the gap of data availability, right? But I would invite you to think about two things. Is it scalable and is it generalizable? So scalable meaning if you want to create this type of regressions, right? So you still need to generate a considerable amount of simulation to begin with, right? So that also means there will be a lot of resource put into there. So think about if you add another 0 to that number, how much more time do you have to spend, right? So, and then generalizability is that not every industry will have this nice user interface-based software. So how can you generate those synthetic data to begin with, right? So very good progress, but we still need to do something about it. So that's about missing data when you don't have data, right? Another example is when you have the foreground data. Let's say you have how much electricity you need to use, right? Then how do you pick the background data for BC? Naturally, you will go to a database, say, okay, here's a BC electricity grid, then you get it. So that's the simplest situation. But in reality, when you do LCA, when you, for example, when you want to use a particular fertilizer with certain amount of, for example, phosphate in there, certain recipe, then when you look at the database, it's very likely you cannot find exactly the same one. Then you have to look at each of them and try to find a close enough one, right? So this meme actually is a very realistic reflection of senior LCA consultant, right? So you spend a lot of time looking at a screen, and with more experience going into the particular field, you can more or less finding the background data quicker, but at the same time, you probably age it a lot throughout the process, right? So naturally, we want to scale up the solution, right? So this is a relatively early publication from a group where what their approach is that, okay, if I know, for example, electricity production, I have some descriptive attributes of my electricity, right? So for example, voltage, right? So the fuel mix. And then I can code those descriptive texts, based on a word and make that into the vector, right? So you convert the string into the numerical values, and they do the same thing for all the available options. Then you can calculate the difference between the distance between the two vectors, right? Using different distance matrix. So as long as you can do the calculation, computer can do it for you, right? So then it's going to scale up the process. Again, 2 questions. Is it scalable? I think yes, to a certain extent, right? So think about this. For electricity, you need to find out some attributes. For fertilizer, you need to find out some other attributes. So it's very case specific, right? So you still have to spend a lot of domain knowledge into finding you have to handcraft those features you want to use for the basic encoding process, right? And then in order for this to be generalizable, you have to have a really large knowledge pool to understand each individual process, products processes. Then you can pick the useful description and then do the transformation into vectors. Then the calculation takes care of itself if you have the algorithm, right? So to me, again, this is just this disclaimer. That's my observation, right? So to me, this is a very good step forward, but we still have space to improve, right? And I will invite you to think about if you ever do LCA, right? So I invite you to think about for a second, right? So these 2 challenges, right? So missing data and also how do you scale up the matching process between foreground and background? The fundamental challenge is basically you don't have time, right? So, and the reason why you don't have time is you probably don't have enough knowledge so that you have to learn things first. Then once you know, for example, I know where to find the electricity for BC, I know BC electricity is mostly hydro, then within a second you can find results, right? So one dream skill, at least for me, is being able to learn things overnight, right? So it's very common if you're working in an LCA consulting company, you're taking different projects, right? So you do projects for beverage, you do projects for textile, you do projects for a sports event. You need to learn those things very quickly. But as human, it takes time, right? So if somehow we can learn things instantaneously, or we are trained with large enough domain knowledge, then we can quickly solve these two, not solve, let's say, let me take a step back. We can quickly mitigate the two challenges I just mentioned, right? So that's where large language model comes into play, right? Because especially I think since last year, there's a lot of good pre-training done. So you can actually ask a lot of good domain knowledge questions to, let's say, ChatGPT or many of other like large language models, and you get a pretty accurate answer, right? So of course the accuracy is open for debate. I'm happy to take any questions based on this, right? So so that's the motivation, right? So we know that as a human, we cannot outpace the sheer amount of knowledge we need to learn. So how about we turn to the recent development of AI that's actually came with this large domain knowledge database and keep being updated, right? So so the next the rest of my presentation is basically going to focus on a few examples about how LLMs can help us to try to mitigate the two grand challenges that I just mentioned at the beginning, right? So first of all, in order to, for example, fill the data gap, you should be able to curate the data in the first place, right? So then you can make the judgment whether it's good or not. Then in order to basically, kind of like obtain the data, the sheer amount is kind of beyond human power to do it. So we need to have automated power, workflow to do this, right? So if you have ever used ChatGPT Plus, anybody use ChatGPT Plus? Oh, many of you, that's great. Yeah, good business for OpenAI there, right? So you probably know, right? So you take a screenshot, pass it to ChatGPT, and it will tell you what's going on. So it's a pretty good parsing of the information in the figure that helps you to quickly understand a very complex, flow diagram. Sometimes you can even get inspirations when you, for example, have a very complex, bar chart or whatever, like a visualization you made. You want to get some insights about, like, when I show people, what does that mean? You can pass it to ChatGPT and it will give you some insights. And then of course you need to check whether that actually makes sense to you, right? So sometimes it gives you really good inspiration because it understands the content, right? And another example is if you pass like a screenshot of a table, it will parse that into a CSV file in many cases, not in all cases. Then you can directly download it as a CSV file. So that helps a lot if you are a student trying to do a literature review and need to find a bunch of tabulated data. Instead of just, select, copy, paste, and deal with, a lot of like the formatting issue from PDF, you can just basically pass it to it, right? So, of course, that's what I always tell my students is that now we're at the time where we can do this is a little experiment you can try, right? So we can do experiment for prototyping at a relatively low cost and a low technical barrier, right? So once I know I can do this by using ChatGPT, I can basically write a code pipeline using those Python libraries, and then I can basically just pass in the PDFs as many as I want, and then it will just extract the different modes of data for me, the figure, the table, the text, right? So instead of me uploading PDF to ChatGPT and download things, it still takes time, right? So, and it's also a discrete operation. You can just write a pipeline and just automatically, pass along as many PDFs as you want, as long as you can pay for the token and all these things, right? And then once you get those information, then you can use other type of high-level Python libraries. For example, some of you are probably familiar with the Llama Index, right? LangChain. So that actually will help you. For example, if you write a prompt, you can ask like, for example, if you run your PDF through unstructured library, right? So it will extract images. So not only the flow diagram, not only the bar chart, but also the logo of Elsevier, right? That's probably not what you want. Then you can just write a very simple prompt and give it a few shots saying, okay, don't extract the logo, or just discard the logo if you extract it. Then you will land on the kind of the figure you want. Of course, you need to tweak your prompt a little bit. But that whole pipeline speeds up the screening process for you to get information you want, right? You can also do the same thing as you should before, parse the tables, do some cleaning up, and save it as CSV, and then you can use it for downstream operation. For example, feed that into a LCA model, right? That's how you can get data. So this is one example of my master's student's work. Basically, what he did is he collected a bunch of LCA papers. Let's see if I can show you. Oh, nice. LCA papers here. And then what he's interested in is the inventory table, right? So the input, like energy use, material use, waste generation, right? So what he did is that he basically has a pre-trained classifier looking at the information from the PDF and say, okay, here's the tables I want. And at the same time, you need to basically embed your PDF, making that into a vector database. Then you can start to look for information by calculating the distance between the vectors, right? And then with those two pieces of information, as a human, you can come in and quickly screen out the table you want out of, let's say, 100 different PDFs, instead of you reading through all the tables, right? So that speeds up the process. And the lower part of the pipeline is that once you have those information in the CSV file, and then you can do another step, which is using a platform called Neo4j, basically that uses the Cypher language that organize the information, CSV file in a structured way, right? So the things from the PDF are unstructured, right? Then once you kind of lay it out as a knowledge graph, they're linked, right? So you can have, for example, this author has this paper, and this paper has this title. The title links to, for example, the abstract of this particular paper, or this paper contains, in this case, if we are interested in looking for methane production. So then you can do a quick search and see, oh, out of this entire database, here are the 5 papers that actually involve methane. And then you can keep searching for, for example, if you ask for the information of electricity, then it's going to go through the knowledge graph and see, okay, this particular methane production has the electricity input, right? Then you can put them out and then do some simple math, for example, taking the average. So that's a whole pipeline as a prototype again. So of course, that's not perfect, but we want to demonstrate it's possible. You start with a bunch of papers and you end up with a user query for the inventory data you want. So that's how you can use large language model to curate the data and hopefully kind of bridge the missing data gap if you don't know, in this case, what is the average electricity consumption for methanol production, right? Of course, as I mentioned, it's not perfect, right? So for example, we all deal with tabular data, right? And then we know table comes in with different flavors, right? So you have table look like this, and you have some nested, like titles, merge cells. And that's where the current development of unstructured data extraction is after. They try to actually be able to accommodate different types of tables so you can all get a very consistent output, right? So to me, because my research applies hopefully the most recent advancement in, for example, large language model, computer science. So I'm just waiting on them. So I know I have the pipeline. I know I don't have the perfect tool yet, but whenever they have a new tool, I just plug it into my workload and it solves my problem, right? So I think that's kind of a pretty cool application. And another one is, if you think about doing LCA, in many cases, your product. For example, I know it's Apple, right? But if we go to the database, basically you probably have a data called like a MAC attach, right? So actually, I have to admit, I didn't know MAC actually refers to a certain type of Apple until probably a few years ago. So then in this case, right? So you probably don't know which one should I pick, right? So, but they're basically more or less the same thing, right? So that's why in the LCA field, there's one direction where people want to go with is to harmonize the different name that refers to the same thing, so that when you are creating LCA, you're actually not looking at missing data. You're just not finding the data that's there. You're not seeing it, basically, right? So that basically speaks to data interoperability issue. And then this particular paper lay out a few of the efforts you can take. They basically define a structured approach for example, 2 groups of people looking at 2 different databases, and you feel like if these 2 things if you feel they're the same thing, there's a certain procedure you can follow, and then you can hopefully end up saying, okay, we agree that's the same thing, right? So this basically means as a human can keep going back and forth, looking at the procedure, looking at a paper, but as long as you have the rules nowadays with a properly crafted prompt, large language model can do a lot of those things, right? So we, like in the previous slides, I showed how it can actually extract the information in the first place. Then you can actually have a pipeline for it to actually determine whether these two are actually the same or not. Of course, it's not perfect, it's far from perfect, but again, that shows the possibility for us to actually expand availability of the data that actually are there, but we didn't recognize them because they're under different names, right? And also another example is some of you probably use OpenLCA to create LCA models, right? Some of you probably use Brightway, which is a Python-based LCA, like a software. They have the same purpose to do LCA, but currently, if you build a model in OpenLCA, it's kind of hard to translate to the community where they use Brightway. Then this basically means we do have the data, but the availability is just a barrier of translating the same model between two different software, right? So there is a Python library that's being developed called the OpenLCA to Brightway, but as soon as you start to use it, there's a lot of problems because one thing is that if you look at the two software, basically this is one example of defining the property. Flow property can be like units, can be whether that's a physical flow or something, energy flow, right? So if you basically if you want to define the same, let's say mass flow of things, they have different fields that you need to fill out, right? Then this means if you're missing something in one software, you will likely run into error of translating to another. Okay, I need to speed up, sorry. Yeah, so that's why, again, you can use large language model to actually find a pattern matching, right? Okay, I'm gonna skip future work, but feel free to follow up if you have any question. All right, so that's about the missing data. So let's think about background data matching. You actually have the foreground data, the quantity of the data you want, but which background data should you pick, right? So here's one example, right? I hope we all agree the first image is a panda, right? And that image is also panda, right? But if you ask the early time image classifiers, once you add a little bit noise to the original photo, it will be classified as a very different figure, right? That has a very profound implication to, for example, the safety of the algorithm and all these things. So, but the moral story here is that in many cases, the machine learning algorithm doesn't really understand things. In this case, it doesn't really understand the semantic meaning of the image, right? So it's a panda. It's not just a bunch of random pixels, right? So, and the story I'm alluding to is when I do some, like a whole building LCA where I want to look at the embodied carbon of building materials, I feel like, okay, instead of manually picking stuff, I want to do a automatic process to pick, for example, concrete, find a concrete for me from the database. And it worked reasonably well until you run into a situation where if you have some straw for insulation, it will pick strawberry for you, right? So this early type of algorithm doesn't really understand, again, the semantic meaning. So, and now with large language model, you can write a prompt and ask it to pick, for example, the reasonable background data set for you. And it worked reasonably well, better than the previous one because it has some semantic meaning, understanding capability, but still sometimes it didn't really work well because it will hallucinate, right? So for example, I know the database doesn't have something called watermelon, so you would never find a watermelon, but I just want to see what it actually gives to me. So it actually gave me a really interesting justification of picking that one. Then how can you reduce this, mitigate this problem is you can use what's called the RAG, right? So retrieval augmented generation, where essentially you provide the LM additional context of the question. In this case, I just gave it a markup context saying that watermelon is type of fruit, right? Then it gave me something that's more reasonable, right? So you have watermelon that, should be part of fruit. So again, that's just a very preliminary experiment. Then there are papers already, for example, this group from Amazon Science, they published this paper saying that, okay, if you give a description of the carrot, it will pick a particular sector in the, for example, USEIO, environmentally extended input and output table, which you have different sectors. It will pick one that's most reasonable for carrot, and then you can use it to do the calculation. You can do the same thing for eQuickMap, the process LCA database as well. All right. Quickly, that's where if you want to make an assumption, right? So you assume that that's the background database I want. But what if you want to validate other people's assumption, right? So in many cases, you rely on other people's assumption of what background data they pick, right? So this is a So if you follow my Twitter, you probably see a lot of goofy tweets, but this one is serious one because I read this from an email list where we have LCA practitioners talking about different modeling options. So here, basically, this person is trying to ask whether this treatment of reinforcement steel recycling is good for his or her LCA model. Then this gentleman is, I think, probably the most in this planet database. So he gave a really kind of detailed explanation of the. But this got me to think, like, I don't have that knowledge. What should I do when I see this? And also, paper I'm citing, they have this level of knowledge, so they make it the right choice, right? So you need, and I do want to play this little meme here, right? So you need
your system. What's that? Your system. What's your system?
Right. So you hopefully don't land up you say, okay, there are two. I just randomly pick. Right. You have to have a system. So in this case, what you can do is, again, you can use large language model to cross-check with based on different source of information, right? So if you have a text, somebody said, okay, they cite my 2050 paper, hopefully, right? And then you can check whether in the reference session, you can actually check that, did I actually say this, right? So, and also you can check, for example, between the background data you pick from the eco event and the process description in the LCA paper, do they actually match, right? And of course, you can identify missing data as well. Here I want to highlight that with help from Cloud Innovation Center at UBC, we do have this center. They work with Amazon. I mean, when I say we, they attribute this particular pipeline you can deploy. So here's the name of the GitHub repo. Everybody can basically follow the instruction and deploy this whole system as long as you pay for the AWS service, where you can start with your own client. You can authorize, for example, your student who can upload PDFs and then do a bunch of backend operations, and then they will be able to, for example, validate, does the author actually say this, or what is the assumption going into this particular paper. All right, so I want to land my presentation kind of overarching picture of my group in this particular research field, right? So the vision is really to be able to conduct transparent, consistent and accurate LC at scale, right? So in order to do that, we have basically 4 strategic projects. First one is focusing on information retrieval. As you just see from the previous slide, we have the infrastructure built thanks to the CIC, and I have students basically testing out different RAG algorithms to do scientific discovery. So ideally, we can have a pretty good pipeline that like extract the information in the first place. Then we need to do the validation part, where I try to work with my collaborators at Amazon, actually try to kind of build up the pipeline where we can validate for them the assumptions. And the third one is, which I kind of skip, is we try to find a way to do LCA differently, where we try to separate model from data. So because again, the model describes the physical system, right? So if you're talking about how to grow apple, however you model your LCA, it should be the same way of growing apple, right? So we want to use, ontology-based method to actually enable people to share the underlying model without much variation. Then you can just pull in different data from your local grid or from different fertilizer you use in a different way. So we try to do this kind of automated LCA calculation using a different approach. And all these are going to lead to, for example, the database creation in this case. All right, so I think I will stop here, and I may be able to share the rest of the slides where I talk about some of the critical questions we want to do. Or maybe some of the questions will lead to that as well. Thank you. Yes, sorry, I kind of rushed through a lot of content, so probably take a second to recap. Okay. Correct. That's a good question. That's actually what, so the question is how do we our group interact with the ontology experts to develop this part? That's a very good question. That's also one of the reasons I like to do this kind of public presentation is that I've tried to solicit collaboration from experts because I'm not the experts, we're not the experts, but this particular company we're working with, they have some good talents in ontology. So what we're trying to do is if you're using ontology, you need to have two sets of ontology. Process, impact assessment methods, right? So that should be universal. If you look at the literature, about say 15 years ago, people start to look into this particular approach. So we are still trying to agree upon a LCA ontology. Then that LCA ontology need to be collected, connect with a domain-specific ontology for particular products. Which, for example, if you're looking at fuel production, I think there are ontology on, for example, at least fossil like petroleum fuel production, like what are the major nodes in terms of refinery and process, what's the relationship. So these two types of ontologies will need to be connected in order to realize this. So we're actively looking for collaboration on this part. Thank you for your question. Did I answer your question? Emily? Yeah. Thank you. That's a very good question. So Emily's question is, we start with feeding the paper into the pipeline, right? So manually. So can we actually even automatically find the paper and feed it into our pipeline? The overall the answer is yes, but we're not there yet. So one thing I experiment with is that you can, for example, crawl the website where you have a list of publications, right? So then you get a link to the publication. Usually it's a DOI. Then you can use Crossref API to access the DOI, and then you can extract all the metadata, like author, like title, publication date, and then the next step is to feed that, let's say, metadata into Zotero. Zotero has its own API. Then Zotero, based on that metadata, will be able to identify those papers. And for now, still you have to do the final kick, which is in your Zotero client, right-click, and then I think the option is called fetch PDF. Then you get all the PDFs just automatically, but you still have to do one kick. But I'm pretty sure this is already kind of outdated way, but there must be even better ways. So yeah, the short answer is yes. Yes. That's a very good question. So you asked a $1 billion question to the industry, not just the LC, but I think to Gen AI, right? So so how do we actually detect hallucination? So one thing is I'm confident that, for example, the large language model community is keep working on this. They have different sets of guardrails and techniques. But based on my own experience, is there's some ways we can, first of all, reduce the hallucination. For example, the RAG I just showed you, and the RAG itself is quickly evolving field. Every day you see new paper talking about how do you provide suitable context so that your model does not hallucination. So the very simple one everybody use is in your prompt. In the end, you add one sentence. Oh, just say don't know, do not. So that actually works magically well in many cases. Then, of course, by providing better content help, and even in some case, if you want to fine tune your own large language model, right? So many of the large language model, whether it's closed source or open source, you can get a license to fine tune that, meaning that you can feed your large language model with a data set where you have a question, for example, what is system boundary of making an Apple computer, and you provide it with the answer. So you give them large enough and diverse enough data set, like instruction, answer data sets, then you will change the weight of the transformer. And then it will be tuned towards answer the LCD question you give to you. Of course, that's very expensive. But that's another option to do this. And then another one is really a lot of people trying to do is to use what's called the LM as a judge. So there are certain way of basically program your LM to be a critique of your, the generation of the other LM to do the cross-checking. Then always have human in the loop. It's going to be helpful. Yes. Yep. Well, no, never too late. Yeah. That's a good question. So we are using, in my group, we primarily using OpenAI's. Now we're using OpenAI 4.0, and sometimes we use Mini just to save money. So basically, the GPT-4 Turbo is the most powerful one. As you can see, it's basically always on the top in the leaderboard. We did use some kind of open access free ones. I won't name them because they're okay. They're not as good. Then the cloud, the latest cloud and also Llama model are pretty good as well. Actually, I would suggest really start from. So like in my group, we really start with OpenAI's, GPT-4.0 because it's reasonably priced and it's fast and it gives you reasonable output. So it saves a lot your time spent on really kind of debugging your pipeline. So yeah, I mean. Thank you very much. So that's a very good question, Amanda. Actually, that helps me to actually jump through a few slides. So that's actually leads to some of the slides I didn't get a chance to show previously. One is humans should be involved in really defining what is the AI compatible data set for LCA in this case, right? So I don't know how many of you actually read this book. Very good book. If you haven't, basically, so the Professor Fei Li actually mentioned the story about how they came up with this image net, and right, so they have a systematic way of defining the metadata of the data set, right? So how do you find a diversify enough data set and all these things? That requires human. That's a lot of the human resources put into this field. And I'm going to skip this one, right? So another one is because we're human, we're interacting with large language model. So the first interface is really prompt, right? So that's where I think, at least as of now, we still rely on human to generate prompts. So having a good prompt data set is very helpful as well, right? And then I'm going to skip this one and refer to my last meme here, right? So that's also where human is very important. So how do we create a good enough data set, right? So when you do LCA, I think arguably you never get a perfect answer, right? So for example, you just think about diesel, right? So create a LCA model where you say, okay, I use diesel, but I use this type of diesel, or this diesel actually produced through this particular pathway. They're all plausible, right? So you cannot necessarily say you're picking the wrong diesel in this case. So this means there's unfortunately non-zero uncertainty among human to solve this problem. So that's where I think humans are very important, is to help AI or large language model to kind of get into that range, like a margin where they can actually resemble human uncertainty, right? So I think we're not expecting AI to have zero uncertainty, while human ourselves will have this uncertainty, right? So that's where I think coming in and really define how good is good enough is a very important use of human power, I guess. Thank you. Yes. For like a metadata. So the yeah. So the question is, can we use LLM-based pipeline to do meta? You involve a lot of human like activities of even finding the data, finding the reference and extracting information, things like knowledge, right? So that's what we're trying to do in my group. Is now our literature view will never be the same. Right? So try to do that. And but before large language model, I had the fortunate to attend a workshop, kind of given by a very renowned researcher in our field, a professor from MIT. Some of you probably met her. So that was back in 2016, I think. So her group is using NLP, natural language processing, where you actually try to do the text mining from a bunch of technical paper. For example, how do you make a catalyst, right? Then you find a sentence, you extract the entity, right? Here is, for example, the material, here is addition, here is the yield. Then the pipeline will basically give you a recommendation when you ask, like, if I want to make this, for example, zeolite-based catalyst, what are the temperature range? What are the material? So that's before people are doing this. So I would imagine with people are doing this more and faster, I guess. But that's a very good question. Other questions? Yep. Yes. Correct. That's a good question. So the question is there a international standard for doing LCA? The answer is yes, but so ISO standard, if you read it, it's really high level. It's a guideline about what you should do, what you shall do or shall not do, but it's not like step by step, like a blueprint of doing LCA. So still, by reading through the guideline, when you do LCA, there's still a lot of latitude of doing things. So yeah, so that's also something I've been in discussion with some of the collaborators is how can we create a QC, like quality control agent using large language model to say, okay, here, those are the reasonable steps you take, right? So one direction I'm thinking about going is, I don't know, you probably heard the term called product category rules, PCR, where it defines how you should do LCA for a particular category in order to generate a report called EPD, Environmental Product Declaration, which is basically like a 5 to 10 page of report of a LCA for a product, for example, a cubic meter of concrete, right? There's certain rules to do LCA that's more specific than the ISO standard, that's based on ISO standard, right? So ideally, if you have those clearly laid out rules that even better in a structured way, then you can basically have an LM-based pipeline to enforce the checking of those rules. Then that will be a good first step, I believe. Did that answer your question? Yeah, no. Yeah. Yeah. Right. We still do it. Yeah. Yeah. Yep. Yes. So I think that speaks to this. If you can not tell, does that matter, right? So it really, I think that's a very good example. Is in order to probably answer this question, is we probably have to focus on the second part of the sentence. What actually matters, right? So there are a lot of, from the LC perspective, there are a lot of techniques of doing, for example, uncertainty analysis. And basically, in many cases, you'll say, okay, if I don't know this number, or I just give it, a reasonable educated guess, the result doesn't really matter that much, right? So, but we do it in multiple ways. There's no agreed upon way of how to test whether it matters or not. So, but I think that's probably the next direction we should go. And also for Wikipedia, I had the same comment. Like like when I was a graduate student, I was like, okay, that's pretty nice, right? Why can't I just cite it? So yeah. Right. No question? Okay. Okay. Thank you very much. Really, thank you for the questions. Yeah.